We have the area formula for a triangle. We have the area formula for a rectangle. Trapezoid, parallelogram, circle. So area involves square units, the little squares that fill up a shape. Watch this. We got a square. Okay, so there's a square there. Ariana, what is that square called?
Is that 1 inch? I can't read that.
Well, from here to here is 1 inch, but what is that kind of square called?
Oh, that's I forgot, sir.
It's okay. Every edge on this square is 1 inch. So we would call this, what do you think, Robles?
We're just talking about yesterday.
Right. This is like a construction. If you're ever in construction, if I had a construction, we're going to go, oh yeah, that's a...
1 inch square.
What was that?
1 inch square.
Right, or a square inch.
Square inch, yeah.
That's a square inch. It's a square where every side's an inch. Watch this now. Stay with me. Let me copy and paste this puppy. Watch this now. What's that called? You're close. That is a square, but a square unit would be a square where we don't know how long each edge is. That's just a square unit. This is actually a square foot. Yeah? It's a square foot. In construction, if you want to redo your roof, I was telling Ariana, when you go to Home Depot, they ask you how many square feet do you need of roof. Like that's the area, the flat area of your roof. How many square feet fit on your area of your roof? Okay. What's that called? A square centimeter. And you guys did that with the little project I had you doing yesterday. Every little square was a square centimeter. Okay, so far so good. You kind of getting the idea? That square units can come in different sizes. They're always squares, but I would use this to measure how much carpet. If I want to recarpet this room, I'd use square feet. I wouldn't use square inches because that's too small. I use square feet. How about this? Check this out. Let's just pretend every edge is actually 1 mile. What's that called?
A square mile.
That's a square mile. How many square miles fit in Pomona? Let's see. Check it out. Piece of garbage. Look at the area of Pomona. Look at there. There it is on the map. Do you see Pomona there? So it said 22.9 square miles would cover Pomona. the city of Pomona. 22.9 of those would fit inside Pomona. So I want to get in your mind the concreteness of what square units are. That's what area means, is how many squares will fit in a shape. Now, here's the formulas for them. How to find the area of any kind of shape. How many square units? How many square inches will fit in this? How many square feet would fit in something? That's how we find the units. That's the units we use. Now, I want to get into three-dimensional stuff now. In other words, solids. Look at this thing, a prism. You guys made one yesterday. You cut one out and you guys actually made a prism. You didn't know what it was called, but it was called a prism. Sometimes they're just referred to as solids. Okay? I finally got that purple solid out. Look at the solid in my hand. Right now it's flat and two-dimensional. It's two-dimensional because it only has length and width. But when I fold it in on each other, now it's 3D. It's got length, it's got width, and now it's got height. So if I wanted to find the volume, well, before I even do that, let me get out of. Let me get a prism going here, watch. So here's a prism. Go ahead on your notes. Go ahead and try to draw a prism for me. So the way I do it, just a little FYI, I draw like the top rectangle first, like this. Then I draw a bottom rectangle the same way. And then I kind of connect the corners. The dotted lines add like a 3D effect. See what you could do. I'm going to write the word prism. Go to write the word prism and put an arrow on that gizmo. Go ahead and shade in one of them, one of the faces, one of the sides of the prism. Shade in that. So I have this prism in my hand. Go ahead and put an arrow there and go and write face. How many faces make up this prism?
6.
There's 6 faces, huh? 1, 2, 3, 4, 5. So there's 6 faces that make up the prism. Okay, so far so good. Now, let's say this was 6 feet long right here, this edge. Go and do that for me. Let's say this edge was 4 feet long. And let's say the height was, let's see, 4 feet long also. No, let's go 5 feet long. 5 feet. Okay, so far so good. Now we could find the area of one of the faces now. Let's find the area of the side face right here. So we're going to put area of side face. Right there, that side face. What kind of shape is that side face? That's a rectangle. So look at the area of a rectangle formula. So let me put equal here. The area of the side face is going to equal, let me see, so it's a rectangle. So let me go back up to my formulas. that I copy and pasted earlier. The area of a rectangle is length times width. So let me go and write that in there. Here we go. So the area of the side face then is going to be length times the width. So let's look at that side face. What's the length of the side face and what's the width?
4 by 5.
Exactly. I like how you're saying that too. 4 by 5. That's typically in construction language. If you're going to describe a rectangle, they say something by something. Very nice. 2 by 4, things like that, right? So this is 5 feet. Look at it, because this edge and this edge are the same, and they're the same as this over here on this side. So I already know the length is 5 feet, and the width is 4 feet. So I'm just finding the area of the side face. Let's rock and roll. So the length is 5 feet. The width is 4 feet. So far, so good? So the area then is 20 what?
20 feet squared.
Nice. I could teach my grandchild, oh, it's 20. But 20 what? If you tell me what the what is, then you're telling me you understand what area means. In this case, we're talking about square feet. Everything's measured in feet, so we're talking about these. 20 of these would cover that side face. 20 square feet. That's a square foot right there. 20 of those would cover the side face if it was actually drawn in real life. Let's keep going. Look at it. You can write 20 feet squared like that, or you can write 20 square feet like that. Either way, it's fine. This is more easier and quicker. That's the area this is. Okay? Now, last problem. How do you find the volume? Now, when I say volume, I'm not asking how many cubes would fill up the prism. 3 dimensions now. How many cubes would fill up this room? Imagine I'm just putting a bunch of cubes in here. That's a volume question, not an area question. So my final units would be, watch this. If I'm going volume, I'm now doing, check this out. Look at this. Can you imagine a cube where every edge is 1 mile long? Can you imagine this gargantuan cube where every edge is 1 mile long, how much stuff you could fit in there? But what would that be called? What kind of cube is that?
Mile cube?
Switch it around.
Cubic mile?
Cubic mile.
Cubic mile?
That would be a cubic mile. I know how huge that would be. Or what would this be called, Mr. Robles? Every edge is 1 foot on the cube.
Cubic foot?
A cubic foot. Diana, what would this be called?
Cubic inch.
A cubic inch. Robles, what would this be called? Okay, we're getting the idea. That's what I'm asking now. I want to know how many cubes would fill up this prism. Okay, so let's find the formula. Look at the formula right here. It's on your formula sheet. I actually copied and pasted that puppy. Look at it right here. Volume, length times width times height. LWH. Just multiply those puppies. So let me come down over here. Length, width, height, 3D, 3 dimensions now. So the volume then, the length is 6, the width is 4, the height is 5. Right, Robles?
Yeah.
6 times 4 times 5. Just separating all the numbers by parentheses. Here we go. We get my calculator out. 6 times 4 times 5. Nice. So I'm going to put V, 120, chickens, horses, termites. What are we counting, Mr. Adriano?
Foot square. Or
Volume.
square foot. Wait.
Volume, huh?
Cubic square.
Keep going. You're there. These. That's a what?
Cubic foot.
So 120 cubic feet.
How do you write that?
I'll do it right now. So 120 of these would actually fill up this prism. If this prism was actually life size. It's actually not life size, I'm just drawing it on the board. It would fill it up. 120, watch this now. Good question. How do you write that? 120 feet to the third power, that means a cubic foot. Or you could write cubic feet. Now, with the prism you made yesterday, I have yours in my hands, both of you guys'. You're going to take one picture and put it in your Adobe Spark slideshow, and you're going to tell me the area of one of the faces. What face do you want to tell me the area of? Notice I'm asking for area. And then the second slide is going to tell me what the volume is of this. And you're actually going to fill this puppy up with cubic centimeters. I'm going to put a bunch of cubic centimeters on your table, and you're going to fill it up, and you're going to figure out the volume by counting the cubic centimeters. And so your slideshow will be 2 slides. And the directions are right here on C17. Just watch that video and I give you the directions of what I want you to. I want at least 2 slides. One for the area of one of your faces, and one for the volume. Once you're done with your video, post a link. Turn in the link on this. That's what you'll turn in the actual link, because Adobe Spark spits out the link because they save your video on the cloud, and so your video will have a link. That's what you're going to turn in to me, and you're done for the day. So you're only going to find out the area of one face and the volume of this that you made, and you're done for the day. Come on now. I'll play some classical music. Watch my video and I give you the directions. It's easy.